part on this computer. Looks like I'm recording. Yeah, that's it.
Okay, great. So you guys, we're all, this is the first time I ever taught using Zoom, so you'll have to forgive me if I don't know exactly what I'm doing all the time, but we're all in the learning process here. So, okay, so can everyone see the agenda? Because I can't see it.
I can see it.
Okay, so we're going to start with a little short, very short Kahoot review of chapter 1. It's got like 8 questions, and they're about, it doesn't count for anything. It's just more like, do you remember this stuff, and are you going to just to make sure that you're not going to miss certain things that are key to what we're doing going forwards. And then I'm going to do just a quick little Desmos demo just to make sure everyone knows how to use, pull up the Desmos, just because I think it's, and I know Matthew said Wolfram as well. Those calculators are great, and they're free, and they'll make your life much nicer if you know how to use them rather than a phone calculator.
And someone was asking about extra practice and stuff, and they mentioned the website before I did, but another website I also highly recommend is Khan Academy. Yeah.
Also, Purple Math. There's a bunch of websites that can give, that you can find all kinds of stuff on. But yeah, Khan Academy is awesome. All right, so then after the Kahoot, we're going to do, this is the, I plan on, we'll do several, an example for each group of problems on the homework. And then I'm going to put y'all in groups and let you have like 5 minutes to work on it. And then we'll, because each problem set has like 3 to 4 problems. Work on those, come back as a group, and I'm going to call on people and kind of just randomly, but if you're, I don't want that to be intimidating at all. So if you're like, I'm just really not comfortable answering that, or I'd like to let someone else in my group answer that, that's absolutely fine. Okay, so no problem there. So that should take most of the period. Then we're, what's due tomorrow is, or due today by 11:59 is the chapter 2.1 book problems and the worksheet. And again, just let me remind you, try to scan them as a single PDF document before you submit them.
So chapter 2 today, oh, sorry.
Yeah, and that will be good. And then before class tomorrow, you need to download the notes from Maricheck 2.2, watch the video of Maricheck 2.2, and fill in the notes before you come to class, and be prepared to work on book problems for 2.2. First test will be Thursday of next week. Wednesday of next week will be review. And then Friday of next week we'll start a new unit. And then of course we have Labor Day weekend on Monday.
Can I say a little something about the test, I guess? Okay, so we're going to do our testing in it's called a lockdown browser and respondus monitoring. It's too early to say words. So you're going to need to download the lockdown browser. It's a separate like sort of browser thing that they have, like Google Chrome, or I think E is going out of business now or whatever. But it's just a browser that you download, and when you take the test, it locks you out of every other program on your computer, basically. And so it prevents you from opening other programs. And then the monitoring, you're going to need a webcam, and it's either like, if you can use either like a built-in webcam or something with the USB. It doesn't really matter. I'm not sure, but you might even be able to use your phone like I do. And use that as a webcam. I'm not really sure how that works.
I bet you can.
I think you just have to show your face, but I'm not really sure how that program works, to be honest. I did just send out an email, and so there should be that. And then the other thing is there will be a practice quiz. I haven't made it up yet, but there will be a little practice quiz for y'all to practice the whole process, and I'll get that up definitely before tomorrow's class. It should be up pretty shortly. It's my next agenda. So,
and if you want, I also put up a review for the test, and I haven't, I'm pretty sure it matches everything. And again, before tomorrow, I'll make sure that it actually matches, exactly what we've been doing. But before the test, during the review period, we'll kind of stress things that really you know, you should be totally ready for the test when it comes on Thursday. So, all right. So let me go ahead and get this down, and we're going to go ahead and start the Kahoot. And again, please participate if you can. It will, I think it's helpful. And now, okay, so can y'all see the Kahoot screen now?
Yeah.
Okay. All right.
Okay, so we put in that pin. Okay.
Yeah, go to www.kahoot.it, and then that's the pin. Yes.
This is Italian? Is that what that is? Is it like Italian based? The IT?
I don't know.
I thought that was an Italian directory, but maybe I'm wrong.
Maybe so. I don't know. I had never even thought about that. And these are very quick questions. You shouldn't need a calculator or anything. You're welcome to use one if you want. And they go fast. They go pretty fast.
I don't really, it just says you're in. It doesn't say anything else.
Yeah, you
What's
have to
that?
wait till it starts.
Oh,
Yeah.
oh,
Okay. I'm not used to being the host, so I'm sorry. Zara, is that how you say your name? Okay. All right, so we're gonna go ahead and get started. And I can't right now, I cannot see like where I can chat because I'm sharing the screen. So I think that the pin and the number should stay up there. So anyone that's new joining, if you need to know what the number is, just ask us and we'll tell you what it is. But I think it stays up there. Okay, here we go. -10 to the
I'm just showing shapes here.
just click on, yeah.
Oh, sorry. Okay, okay.
No,
So
no.
we look at your screen too.
Oh,
Okay.
okay. Yeah, I know. I felt the same way when I first did this. Yeah, you have to. Okay, good. Most of y'all got that. So -10 to the second is like the negative just sits there and looks pretty. It doesn't do anything. And the 10 is what's being squared. So it's like -10 times 10, which would
So
be
basically, if it's not in parentheses, it's not positive. But if it's like a negative and parentheses, it'll be a positive because you multiply negative with a negative.
That's right.
I got confused on that, man.
You're not alone. That's why I put it on here.
And that'll be like more common when we start plugging things in. You have to look at.
Yes.
Yeah.
Yes. That's pretty, you gotta be careful and not trust your, that calculators know the order of operations, but if you don't put parentheses in the right spots, a lot of times you will not get the right answer.
Yeah. So okay. So this one,
Okay. I hope everyone gets this one now.
I tried to pick everybody's favorite animals.
llama.
Do we have any octopi fans? Ooh,
Any what?
octopi.
Oh. Okay, so this one again, the -10 is in parentheses. So this would be like -10 times -10, which would be positive 100. And I'm glad most of you got that. Just watch that. Okay, so again, parentheses makes all the difference. If the negative is on the outside of the parentheses, then that means that the square only applies to the 10 and not the negative. So the only time the negative is going to be squared is if it's on the inside of the parentheses.
Oh, crap.
Nice. Okay. So make sure that, remember order of operations, you do whatever PEMDAS, you'll always do parentheses, whatever's in the parentheses first. So you take the 5 minus the 7, which would give you -2 inside the parentheses. And -2 inside the parentheses squared would be -2 times -2, which is +4.
Can't see it. Oh. Oh, shoot.
-6, 12.
That's it.
Okay, so most of y'all got it, but let's go ahead and look at this one. So we have 2x squared minus 6x plus 15 when x is -2. So where you have an x, that's where the number is going to go. So I usually just pull the x out, whatever the x is, and put a parenthesis in its spot. And now I'm going to plug -2 in for into each one of those blank spots. And so this would be 2 times -2 squared is 4. And then a negative times a negative, -6 times -2 is +12. And then plus 15. So that's going to give me 8 plus 12 plus 15, which is 35.
So the negatives inside the parentheses and it's being squared with an exponent, it turns positive.
That is right.
Oh, I thought it was the other way around.
Yeah.
What makes us determine that there's parentheses? What rule are we applying here?
Okay. So if you have an X, you're going to be taking that X out, and in its place, you're putting the actual number. So anytime you're replacing a variable with a number, you want parentheses around that number.
Okay.
Okay, yeah. This is totally
Oh, what the heck?
I feel like this is like if someone posted this on social media, they'd all be solving this.
I see so many of these on social media. I'm like, oh my Lord. Okay, nice. Let's go about this. So let's look at it as well. So remember, we're following PEMDAS, so please excuse my dear Aunt Sally. First thing you always want to do is look at whatever's in the parentheses. So I'm looking at what's here first. So I have 8 plus 4 divided by 2 times 2 squared is 4 minus 8 is -4. And then I also did the exponent in there too. And then now I have addition, division, and multiplication. So what comes first before addition is multiplication and division. And you do it in the order that you see it. So this is going to be 8 plus, and the first thing you see with regard to multiplication and division is the division. So it's 4 divided by 2, which is 2 times -4, because we do the next. And then
We're supposed to keep the -4 in the parentheses the whole time.
yes, because now that -4 is being multiplied by something, right? So you don't want to do that till after you've done the division, because multiplication and division happens in the order that you see them in the problem.
So keep the exponent there so they can multiply and divide, part of the PEMDAS process.
Yes, so this would be, I should probably, let me go back. I kind of left off a step. Okay, so what we have is 8 plus 4 divided by 2, and now I'm doing the parentheses, so that's going to be 4 minus 8, right? And now I have 8 plus 4 divided by 2, and 4 minus 8 is -4. And now this whole problem is nothing but multiplication, division, and addition. So the next thing is the multiplication and division in the order that you see it. So the first thing you see as far as multiplication and division is the 4 divided by 2. So that's going to be 8 plus 2 times -4. And then we still have a multiplication, so we need to do it before we do the addition. So that's going to be 8 plus 2 times -4 is -8. And 8 plus -8 is 0. Again, addition and subtraction is in the order that you see it.
So always keep the number inside the parentheses after,
Yeah,
the exponent stuff in parentheses. All right.
right.
Is there ever a time when we're not going to use PEMDAS, like in a straight up addition, subtraction, and multiplication and division?
Nope.
So whenever you see a string of math functions going across, we're always going to do multiplication and division first, no matter what?
Before addition and subtraction?
Yeah.
Yes. And the grouping, like it's the parentheses is the first thing you do. So whatever's inside a grouping of parentheses is
Sure, but I mean, let's say, I mean, I understand this is algebra, but I mean,
Yeah.
let's say that you don't even have parentheses, you don't have exponents,
Okay,
you have nothing but addition, subtraction, multiplication, and division,
right, something like
Right.
that.
right?
Right.
So you're still gonna apply it?
Yep.
Okay.
Yep.
Outside of algebra, does this stop being the case or something?
Absolutely.
Okay,
People don't always know that, but yeah, I mean, it's what would you call it? Matthew, it's like,
What was the question again?
why do we always use PEMDAS outside, even outside of algebra? It's an accepted practice.
Yeah, it's just kind of like the syntax. It's like the
Right.
structure of the language. Like you have to have some sort of structure. And I kind of said this in the video, like there are other cultures that do things other ways sometimes,
Yes.
And you could
Okay.
actually create other systems that are equally valid ways to solve things.
okay. I'm just saying, because obviously, depending on how you do, like what she just wrote down there, you would get totally different answers.
Right.
Yeah.
So for algebra, we are maintaining the way we're gonna do this throughout the class, I suppose.
Yep.
And
Yep.
then, but universally, this is not a mathematical
It's
rule.
It is for our country.
it is pretty much universal though too.
But-
This actually like pretty much every country out there uses this system.
No, that's not what I mean.
Yeah.
Let's say we're not talking about algebra. Wouldn't this be 5 plus 2 equals 7 multiplied by 8?
No.
across
So this is standard in everything, in every
Right.
subject. It is
It's
just like the
standardized.
standard notation that pretty much everyone uses. Like if you use something else, you're kind of the oddball. Like I don't know. Like not maybe that's a bad phrasing, but you're kind of like in the minority, right, so to speak.
Or it's like not using correct verbiage. It's like saying ain't
Okay.
or it's just not right. It's not right.
It ain't right. No.
What if
Ain't right.
you want to express a problem where you're making somebody add some numbers and then multiply them by something else? I guess you'd use parentheses first?
That
or
is
something?
right. Absolutely. This would totally change it.
Okay, all right.
I have a question. Can you just state the rules of negative and positive? I know if you're multiplying a negative by a positive, it will be negative.
Uh-huh.
And the same with division.
I will. So when the timer stops, then I'll go over that too after this problem.
You still
On
use
this one though, and this one, if it's a negative times a negative or a negative divided by a negative, it's going to be positive.
Okay.
do you still use keep change?
What?
Do we still use keep change? Like if there's like two negative numbers being like
Yeah.
subtracted, you change the
This is negative times a negative. Is that what you're asking?
no keep change. It's like adding and subtracting negatives. Like if there's like two negatives that are
Oh,
being
yeah.
subtracted, you change it to like addition and then one number to a positive or whatever.
Yeah. Yeah, we'll talk about. We'll look at that too. Yeah. let's look at this one. And there's several ways you can do this. You can use your calculator if you want to. I have no problem with that. But and that's why I wanted to show y'all Desmos. But let's look at this. Okay, so on this one, it's multiplication. This would be anytime you multiply fractions, it's always top times top and bottom times bottom. So here we'd have -5 times -7 over 21 times 25. Now we could, I think Matt says, what do you call it? Like, I don't know, muscle it out, but you don't want to do that. If you can see that, first of all, we're going to wind up with a positive because negative times a negative is a positive. And then we can see that 5 goes into 25 5 times. And 7 goes into 21 3 times. So we have divided parts of this out. It just automatically makes life so much easier. If everything cancels in the top, you put a 1 there. Because something divided by itself is just 1. And then 3 times 5 is 15. So then let's talk about the, and I know we've talked about this before, but let's say you had -1 times -1. A negative times a negative is a positive. If you had -1 times -1 times -1, that would be -1. If you had -1 times -1 times -1 times -1, that would be +1. So if you have an even number of negatives being multiplied together, you wind up with a positive. And if you have an odd number of negatives being multiplied together, you wind up with a negative. And the same thing for division. If you have an even number of negatives, it's going to be positive, and if it's odd, it's going to be negative. When you add, let's say you have, so if you have 5 plus 8, that's just 13. If you have -5 minus 8, that's -13, because that's like saying -5 plus -8. So you're going backwards and then you're going backwards some more. If you have 5 minus 8, if the sign, in other words, if you have a positive and a negative, then you just subtract the two numbers. So you take 8 minus 5, which is 3, and then whichever numeral is bigger, that's the sign it keeps. So if you had -5 plus 8, again, you just subtract 5 from 8, and that'd give you 3, and the bigger numeral, in this case, is positive, so it would stay +3. Well, I hope maybe. Okay, almost through here. Last question. Which of the following does not equal -16? Okay, so -4 squared, remember, if the negative is not inside parentheses, that negative just sits there and looks pretty. It doesn't, it never goes away. The square does not apply to that negative. So -4 squared is the same thing as -4 times 4, which would be -16. So that one is good. -8 minus 8, both of those have the same sign. They're both negative. So that means you would add the 8s and keep the sign, the negative sign. So that would also be -16. No one thought 4 minus 20 was not -16, so that's good. And then 4 times -2 squared. -2 squared is +4, and 4 times 4 is 16. So that would not be -16. Uh-oh. happened? Unfortunately, that's the first time that's ever happened. I'll send feedback and say, don't do that to me. Okay. All right, sorry about that. I always like to see who wins these things. I don't know, that was a glitch on their part. Okay, so today, I wanted to show y'all before I move on, this calculator, Desmos, and to get to it, you just go desmos.com and go to scientific. And what I like about these calculators is that you can, like, if you want to do fractions, you just hit the little fraction key. And so you don't have to worry about parentheses as much. And so you do like 5 squared minus 12 divided by 16 plus 9 squared, I don't know, whatever. And it just gives you the answer off here really nicely. And you can also go back and forth between decimals and fractions. We don't usually want you to round it, put it as a decimal unless it's exact. Otherwise, we want you to leave it as a fraction. If you have any questions on Desmos or any calculator issues, feel free to ask us about that. Yeah.
So one thing is, if they're taking the test in Respondus, they're not going to be able to use any sort of
Oh, is that right?
Yeah.
Oh, I didn't know that. Well, that's crummy.
Yeah.
That's even in high school when they take the standardized tests, they can even use Desmos. That's really weird. Anyway, okay. Well, sorry guys. You'll have to have a regular calculator of some sort. It's good to know. I didn't know that. Shoot.
Yeah, I hate to like say it because they're like kind of shady spots, but like a lot of times if you go into a pawn shop, you can find calculators.
Now, you know what? That's so true. They have,
Yeah.
the TI-84s are fabulous. And also you
What's
can
the
get
preferred model, you said, of calculator, you guys?
I think I have an 84 personally. Yeah, it's an 84. Anything in that range, like 82, 83, 84. Like when I was in high school, they were 82s. They just keep increasing them by like 1, but they're basically the same calculator with a few more frills each year, basically.
But even if you don't get an TI-84s and 82s are graphing calculators, you can get a really good TI calculator. Don't get Hewlett Packard. They work backwards. But for like $10, you can get a good scientific calculator easily.
Yeah. I know one of the more difficult things we do is matrices. I'm not sure.
Oh, and that. Yeah,
they might need to find something to do with matrices with, and I'm not sure. I used to recommend web browsers last semester, but now if we're doing lockdown, it's not.
Yeah, and matrices, that is so helpful to have. Yeah. So yeah, if you can get a graphing calculator, TI-84 is the best. Okay. So let me pull it up now.
So is there like a bunch of pathway students here in this class?
Is there what?
A lot of pathway students.
Oh, I don't know. Do you know, Matt?
Pathway, is that the high school program? Is that what we're talking about, or is that something else?
Texas State co-enrollment.
Oh, Texas State co-enrollment. I have no clue.
I don't know.
I don't think I've seen anything. I'm not sure if we have access to that information, to be honest. Yeah.
Oh, hold on. I think I've lost my mirroring. Okay, I'm almost. All right, so we're going to go ahead and start the lesson. And I'm going to start with some example problems.
I've known quite a few people myself that have done that.
Yeah.
Yeah. Seen quite a few working for ACC.
Okay, so the first set of problems that we're going to be looking at are just plain old simplifying problems. And when they ask you to simplify, you're not being asked to tell what X or Y is in this problem because there's no equal sign here. So this is just like a phrase rather than a complete sentence. So all they're asking you to do is to simplify, and that just means get rid of the parentheses and combine your like terms. Okay, so on this one, we're just going to first distribute the 3. And you start, when you're using the distributive property, you just start at the number that's in the front part of the parenthesis and then end at the one that has the closing parenthesis. So I'm going to say 3 times 2x is 6x, and 3 times 5y is 15y. Now this is where some people get confused. If there's a negative in front of a grouping of parentheses, there's an implied -1 right there. So if there's no number in front, that's implied a 1. And so we're going to take this -1 and multiply it by everything inside that second group of parentheses. And -1 times 5x would be -5x, and -1 times -y would be +y. And then we come back and we're going to combine like terms. So we have a 6x and a -5x. That's like 6 apples, and you take away 5 apples, and that's going to give you 1x. And you don't have to put the 1 there if you don't want to. And then we have the +15y and +1y, and 15y plus 1y would give us 16y, right? And then you're just through once you've done that. So I'm going to put you all in groups, 5 minutes. Introduce yourselves and collaborate. And when we come back, I'll call on people to tell me how they did the problems. And again, no pressure, no, don't worry about if you're not comfortable with that. Just say, hey, I'd rather defer to one of my group mates. And if your group mate doesn't want to, then we'll figure something out. But there is no pressure here at all. Because I know some people don't really like being called on, but there's also no judgment at all. So just, I hope everybody feels comfortable with that. Okay, so I'm going to put y'all in groups if I can figure out how to do this.
So we just do those 3 problems?
Just those 3 problems for
Okay.
right now. Right, exactly. Okay.
Oh, yeah.
More breakout rooms. Okay, I'm gonna.
Where are problems at?
Hold on, just a second. I'm gonna put them up. I'm just.
Oh, my bad. Sorry about that.
Let's do this. I cannot figure out what's going on here. Okay.
Hey, Mr. Sears.
I'm on mute. Hey.
Man, finally my Zoom worked today. Thank God.
Trying to see. Oh, she's closing them out. What worked? Why are you doing that? No.
Do I leave her?
I don't know. It's gonna do it automatically. I don't know what she's doing. 4, 4, 5, 5. That worked.
And then like
trying to figure, everyone's coming back to the same room and we need to figure this out. Maybe, you know what, maybe,
That seemed to work last
it?
time. Yeah,
Okay.
it was
Okay.
like 4 or 5 people to a room, and there's like 4 groups.
Okay, I couldn't tell what was going on.
It just threw me in a room, so I don't know if that's what it's gonna do. Just like throw me in
Yeah,
a room.
okay, and then I couldn't talk to you, and I was like panicking.
It also threw me in a room, but like it gave me a timer on like when it's gonna kick me out.
Okay, so right now, everyone should be coming back. Let's see if it works. Is everyone back? Who can hear me even?
Here.
I can
You-
hear you.
Y'all can hear me?
Yeah.
Okay,
Yep.
okay, so now can I, okay, cool. So are y'all still in your breakout rooms?
Nah.
No,
Mm-mm.
so nobody's in a breakout room now. Okay,
They
okay,
timed out.
okay, so then let me see. So if I put the problems up on the screen, I wonder if y'all can see them. Hold on just a second. I'm gonna make sure. So y'all need to tell me. I'm putting the problems up on the screen.
Yeah, I'm not sure if we're gonna be able to see your screen when you do the breakout group.
That's what I was wondering too.
Yeah.
So let's see here. So, so I can, so you should, if you can't see my screen, then go to Blackboard and pull up Merit Checkbook Problems 2.1.
Or pull out your phone right now and take a picture right quick.
Can y'all see it? now?
Can see it.
Yeah, I
You
can
can
see it.
Okay, well then if y'all are in your okay, but y'all are not in your breakout rooms yet, right?
No.
Okay,
We were in them and then they timed out.
okay. So 359, 371, and 377 are what we're doing right now, and I'm fixing to put y'all back into your breakout rooms. And hopefully I'll get better at doing this.
Sorry, where do we get the problems from off Blackboard?
Okay, if on Blackboard, if you go over to the left-hand side, it'll say, oh gosh, what's it under? Let me show you.
It's under the course materials or something, class documents,
It'll
under
say-
homework worksheets. If you click on homework worksheets,
Oh, there's a homework.
it is what we're in. What 2-2? No, 2-1 today. Sorry.
And what's the name of the subject today or topic that we're in today? Simplification.
Yes, and solving. We're going to be doing some solving as well. So Blackboard looks like this, and you can pull up the assignments right here on homework worksheets. That's where it's at, under class documents. So does everyone have the 3 problems that we're working on right now?
Yes.
Okay, I'm going to go ahead and put y'all in rooms for 5 minutes, and then we'll regroup.
So since this is a homework, do we just do these questions or do you want us to do all of them, like 9, 10, 11, 12, 13?
For right now?
What are you talking about? I'm like,
For the book, you only do the ones that are circled in the top 3.
Are these part of the signed problems? Is that what it is?
Yeah, those are the 3 first questions on the bookwork.
Yeah, 359, 371, and 377, right? Those are the first 3 assigned problems.
Yeah.
Yeah. I guess they're from 1.5. So we're still in 1.5 technically.
Oh, maybe so.
Yeah.
So you get automatic. This is weird. So you get automatically stuck in a room, Matt. And I thought we had a main room.
I can join like the other rooms too, apparently.
Yeah, but okay. But how do we not just have like a main room? I don't think you can come back just to the main room.
Yeah, not until things time out, I don't think.
Okay. All right.
I'm
I'll
gonna
check.
go.
Okay. But you can join other rooms.
I mean,
Okay.
I'm gonna go try that right now.
Okay. I'll join room 2.
I was about. How's it going?
So far, pretty good. We're just waiting on one person to finish.
Let's see, trying to figure this out.
Take your time. Take your time.
She's in room 1. I'm in room 2. Oh, nice. If you go to the chat, you can just chat with people that are just in your group. Is what it looks like. So I don't know if y'all prefer chat, prefer the whole video conversation thing, but
Now we're just doing via audio.
yeah.
That way.
It tends to be it tends to be a little more direct if you just talk about things and easier.
Right.
Especially with math symbols, it's like how the heck are you gonna type that out on a
Even worse, by the
keyboard?
time we type it out, enough time has went by.
Yeah. There's
No,
like
but so
program.
far pretty good.
There's entire programming languages like devoted just to math.
It's a real workout. At the same time, I'm just glad we can get all this sorted out.
All right, I finished. I was just like a bit confused on 371.
We're at.
Honestly, like just like the beginning.
Okay, so we're gonna be distributing a lot. A lot, just meaning the first line. So you already got 14C into negative 14?
Oh, for 377?
Yeah, did you say 377 or 371?
I said 371.
Oh man, my bad. Sorry about that, bro.
It's
I heard
all right.
77 on my end. Yeah, that one I had to do a couple of times. If it helps, I usually put a 1 in front of the parentheses for n plus 7. That way I know it's like there's going to be a digit there. That way I can count towards it. Otherwise, I'm just leaving n the way it is, and it gets real confusing.
All right, that makes sense.
Once that's finished, just go ahead and distribute 5m to negative 1m and 7, and you should come out to negative 5m. Sorry, like rewriting it out is just a lot easier for me. Hope that helps.
Yeah, yeah, that does make it easier. So like 5m negative 3 times negative m.
Yeah, because when you negative 1n, it becomes negative 1m minus 7.
Yeah, okay. Yeah.
Also, I love seeing faces. I know y'all don't always want to have your cameras on, but if you could take like a selfie and put it into your profile so I can at least see a face, that would be awesome. That way I don't feel like I'm talking into a void and I can.
Are these other people talking?
Nah, I'm just trying to do. I just don't get number 377.
Number 377.
I think it's what's it called? You know the rainbow? Like it's like you gotta multiply across like
Distribute. Yeah.
distribution.
That's
Yeah.
how I do it.
Yeah, because I also did that for 371. So 371 was like 5m. In parentheses 5m minus 3. Parentheses minus parentheses m. And I got like, and my answer was like 5m squared plus 32m minus 21.
Oh, okay. So
I got 27m minus 21.
Because like I thought since like you
got
multiply those two m's, you know, it'll be like m squared because you know they.
Yeah.
Are we talking about 371?
Yeah.
Yeah.
Is this what you're talking about?
I got 4m minus 10.
Yeah.
Yeah, that's what I got for it.
Okay.
I just got 5m squared plus 32m minus 21.
Okay. So look at this thing. There's the two terms in parentheses. What's the operation between those things?
Subtraction.
Yeah, and so I think what you're doing is multiplying, right?
Yeah, I did the distribution like the rainbow things.
No, that's not foiling. That's subtraction. So like, where is it? Subtracting.
Right.
And so right here, you want to put what number?
No, number 1.
Is that backwards? That's backwards, ain't it? Is it?
Nah, that's true.
No, it's not backwards.
It's like backwards when I'm doing it or something. It's weird.
Oh.
With my brain. My brain's going backwards. Sorry. I had to mirror myself. It was weird.
How do you? So you put a -1 right next to the parentheses.
Put a 1 and distribute the 1 and then combine like terms.
Both sides are just next to the subtraction.
So if you distribute it, it should look like what? 5m minus 1m, right? Should be the first thing. And then you should have like a -3, and then this -7 would give you a -10. We're about to be.
All back together. I still need to figure out. I thought I'd set the timer for 5 minutes, but then I looked and I saw that it was 30 minutes. I don't know. So I need to figure that out. Okay, so let's go over these first 3 problems. And let me pull my back up. Okay, so we're number 359, 371, 377. So I'm just going to kind of randomly call on somebody. And again, just you can either tell me what you got or tell me how to do it. That's what I'd like you to do, is actually tell me how to do it. And then we'll get feedback on that. So Elliot, would you do 359? Tell me how to do it.
Yeah, so for 359, I multiplied -7 with 4p, which got me -28p.
Great.
And then I multiplied -7 with 1, which got me -7.
Great. So if anyone has an issue with that, raise your hand or give me some, or just say something, and I'll be glad to stop and go back over it. But otherwise, we will move on.
I simplified it down again to -4p minus 1. Are we supposed to do that or no?
On 359, how did you get that?
Well, so like 28 and 7 are multiples of each other, so I just simplified it down to -4p. And
Oh,
minus
so
1.
you factored it. Is that what you're saying you did? So what you're saying you did is you would have to factor out a -7, and you would get 4p minus 1, like that. But that just takes it back to here, and should actually be 4p plus 1, right? Oh, because.
Okay, so basically I just divided it all by 7.
No, don't do that, because that you can only do that if it's if there's an equal.
Oh, if it's an equation.
Right.
So
yeah,
here
so,
we can't do that.
Right. So here you just stop right here, right? And you're through. Right. Now, the next few problems that we're coming to, you'll be able to do stuff like that. Okay. All right. So 371. Paige, did you get that one?
I don't know if it's right, so
Okay.
I'll try it. I did, it's 14. Oh, so at the end, can you just tell me if it's right? If it's wrong, then I won't tell you how I got it.
Okay. Tell me what you got.
I got 2C minus 10.
Oh, you're doing oh, I'm looking at 371 and you got 2C minus 10. No, for 377, but that's okay. But what did you do? 371?
371, that's the 5M minus
Uh-huh.
3. Yes, I got, okay, well, I got 6M plus 4.
Okay, so be careful on that. So let's look at this one. So this is like a -1 in front of that, right? That's like a -1 in front. So this would be 5M
But always
minus,
have -1 right next to parentheses.
right. If there's a negative sign, that's an implied -1 in front of those parentheses.
Oh, I didn't even see that one.
I didn't put a 1. I distributed and I messed up like that.
Yeah, so just watch, that's why we're doing these kind of problems, just to, because that's a very common mistake. So you're going to distribute that -1, right? And that's going to give me -1M minus 7. And then we can combine the 5M and the -1M. And 5M minus 1M is 4M. And then we can combine the -3 and the -7.
Be -10.
That's right. Exactly. All
Oh, we just
right.
leave it like that. That's our answer.
Yep, that's it.
I saw
Okay,
some
so-
people were doing foiling on this, so
Oh,
yeah, they were seeing that as a foiling problem.
oh, I'm so glad you said that. Okay, so, ooh, that's awesome that you saw that because, okay, so 5M minus 3, and we haven't gotten to foiling yet, y'all, so minus M plus 7. This minus sign separates those two, the 5M minus 3 and the M plus 7, and it tells you to subtract. The only time you're going to FOIL, and again, we haven't even gotten there yet, we will, is if they are back to back like this. That's the only time you would actually use the FOIL or multiplication. Okay, so be really careful because that is a super common mistake that I see on tests all the time, is that people, when they see two sets of parentheses, they automatically want to multiply them together. But that minus sign tells you that you are subtracting those two polynomials.
So that's the reason why we would then drop the parentheses after you move over the negative.
That's right.
Because that's what's confusing me, is because when I'm writing it out, I'm still seeing parentheses. So I think I have nothing left to do except multiplication now.
Honestly, and this is Michael, right? You, right, you, and anytime you have parentheses, that's just, it's a grouping symbol, but when you're adding or subtracting, you can remove the parentheses completely. And the only time you have to worry about changing what's inside the parentheses is if there's something multiplied outside them or if there's a negative in front. So like that 5M minus 3, that parentheses is really not even necessary. It's just, it just grouped them.
Yeah, see, this is what's confusing me about the parentheses. Sometimes I understand it's just a placeholder, but now we have all these rules regarding parentheses, and so I'm trying to dissociate one from the other now. It's just very complicated.
Right. Yeah. You just have to pay attention to, like if you had, like here, that 4p plus 1 is multiplied by the -7. And once you distribute the -7, you're through and the parentheses go away. Here you have a 5m minus 3 in parentheses. The parentheses really are not necessary there at all. But it's like grouping, it's like saying here's one quantity minus another quantity, which is why they wrote it like that. But you can actually just take away the parentheses. You can't do that for the second part because you have to distribute that negative first.
Right, but I'm talking, so that was the easy part for me. I distributed the negative very quickly, but now we're going to drop the parentheses, obviously, but what if there's multiplication inside of these parentheses?
Then you would do that first.
Right, but if we can't, because these are, we're using variables here. So like 5m times 3 cannot be done. You have to do something with that. Right, so I can't just multiply it. So I have to do something else. Maybe just leave it that way, but I'm just saying, you know.
No, you can multiply it.
Oh, wait a minute. Oh, yeah, you're right. Yep, absolutely. Yeah, I didn't think about that. Okay, that would just be 15m.
Yes,
okay.
Right.
Yep. Yeah, what makes these where you can't solve them is that subtracting. Okay.
Right.
All right.
Right.
Thank you very much.
Yes. All right, and then 377, we have 14 times C minus 1 minus 8 times C minus 6. Bree,
Multiply 14 with C.
did you do that one?
Nah.
Did you call me?
Yeah, Bree,
Yeah, I did it.
what did you, how did you do it? Tell me what you,
Okay, what's it called? I distributed, and then I got 14C minus 14.
good.
Negative 8C plus 48.
Yeah, perfect.
And
Okay.
then I added the 8C on the other side to go with the 14C, and I ended up getting 22C.
Okay, so you have 14C and a negative 8C, right? So it's like 14 cats minus, take away 8 cats.
Yeah. Okay, so you would just do it like that. You wouldn't like add it to move it to the other side. You would just like
No,
do it
because
like
there's no equal sign, right? So you can't do,
Okay.
there's not two sides in this problem. It's because there's no equal sign. So basically you're just combining things that go together.
Oh,
So your answer would be like 6C plus 34.
So it would be 6C plus 34, exactly, because you're combining the 14C minus the 8C, and then you have negative 14 and positive 48. And since those two have opposite signs, you're going to subtract 48 minus 14, which is 34, and use the sign of the bigger number, which is bigger numeral, which is 48.
So you can still put 14. I mean, I tripped up because I thought you couldn't put 14. I thought you can't distribute 14 to a variable, but you can. So
You can distribute 14 to every single thing inside of that parentheses, right?
okay.
So like if you had 2 times 5 plus x minus 3y, that would be 10 plus 2x minus 6y. You start at the front and end with it's like this guy tells you where to start, this guy tells you where to stop multiplying.
Okay, is there ever a time it would be non-distributable to something? Only if it had a variable next to it on the outside?
So what, if it was like this, 2 minus 5 plus x minus 3y, that would be like a minus 1 in front there, and you'd have to do the distribution with the negative 1 first, and then the 2 would come at the very end. Does that make sense, what I just said?
Kind of, but not really. You're saying
So
you would distribute the negative 1 before you did the 2.
that is right. So I would distribute the negative 1, and I'd have 2 minus 5 minus x plus 3y, and then I would combine the 2 and the negative 5, and that would give me negative 3 minus x plus 3y.
Okay.
That's what Matt was talking about. Some of y'all were doing was multiplying when there's a add or subtraction sign between the terms. Be careful about that. Also, distribution is only for multiplication over addition and subtraction. So a lot of times people want to say that x plus y squared is x squared plus y squared. You do not distribute an exponent ever. Okay, there's no such thing as distribution of an exponent. So in this case, and we'll talk about this later, this would just be x plus y times x plus y, and then you'd have to use FOIL. So that's another thing that people do that's not kosher. All right, so let's look at example 2. Now notice in example 2, the next few problems are going to be equations. The difference between these problems and the problems that we did originally is that it has an equal sign. And we're going to run out of time here, so I'm not going to put us back in groups because that took up a whole lot of time. So we're just going to stay together to do these next problems. So there's an equal sign. So this time we can do operations on both sides. And this time we actually do want to come up with a valid answer. Like up here, we were just simplifying. We didn't say what, we couldn't tell, I couldn't say M is equal to anything because there is no equal sign. It's not a complete sentence. Okay, so here we have a complete sentence. We're going to do very similarly to what we did in the last problems. I'm going to start out by, I'm working on this side first. I'm going to do the distributive property here. And that's going to give me 12 plus 10 minus 6y. And I'm going to keep on going on the, I'm just totally working with this side till I have it totally simplified. And so I have 12 plus 10 is 22 minus 6y, because I combined like terms. Now I'm going to work with the other side. And I'm going to distribute the negative 9. And that's going to give me negative 9y plus 9 minus 2.
Oh, so it's like two-step solution kind of.
Right, we're working, like we're simplifying one side, and then we're going to simplify the other side.
And then we're just going to move one side to the other and just cross
that
it
is
off.
right. You're exactly right. Negative 9y plus 7. Everyone with me? So now the way I do things, and not everyone does this, but I am a very, very consistent person. I always want to get the variable piece on the left, regardless. That's how I always do it. Some people don't do it that way, but I always get the variable on the left first, and then I get the constant, the numbers that don't have a letter attached to them, on the right. So I want to go, okay, I want to get this 9y over onto this other side. So to get rid of a minus 9y, you always do the opposite operation. So I'm going to add 9y to both sides. So now what I have is 22 and negative 6 and 9. The signs are opposite, so I subtract 9 minus 6 is 3, and because the larger number is 9, I keep the positive, so that's going to be plus 3y equals to 7. And now I need to get the 22 on the other side, and that's a positive 22.
So subtracted.
That is right. So I'm going to subtract 22 from both sides, and I get 3y equals to 7 minus 22. Again, those signs are opposite, so I subtract 22 minus 7, which is 15. And because the bigger numeral is negative, I keep it negative. Now I have 3 times y equals negative 15. I want to get the y all by itself.
You divide 3 and then your answer should be
That's right.
negative 5.
To get rid of multiplication, you do the reciprocal operation or the inverse operation, which is division. So I'm going to divide both sides by 3, and I get y equals to negative 5. Always good to check your work. And I cannot tell you guys how many times it has saved my butt. I am one of those people, I go through, and a lot of times I'm just really not paying attention. I know what I'm doing, and I just get through the whole problem. I'm just so happy with myself. But I always make myself go back and check, and I'm like, oh, thank goodness I did that, because I would have missed it. So I'm going to go back and check it. And again, you don't have to do this, but it's highly recommended. So when you check it, this is going to be 12 plus 2 times 5 minus 3y. Does that equal to negative 9 times y minus 1 minus 2? So I'm going to go through and put negative 5 back in everywhere I have the parentheses. So this is going to give me 12 plus 2 times negative 5 plus 15. And that's going to be 12 plus 2 times 10. And that's going to be 12 plus 20, which is 32. And then the second part, does that equal to negative 9 and negative 5 minus 1? Both of those have the same sign, so you add them together and keep the sign. Negative 6 minus 2, and negative 9 times negative 6 is 36 minus 2. So where did I go wrong? 34 because I did a check. So I did something
Should
wrong.
be positive 36, right? Because you're multiplying in negatives.
Right. But minus 2.
That would
What
make
is
it 34.
Right. But over here, it's 32. So something went wrong.
Hmm.
What happened? 12 plus 2 times 5 minus 3 times negative 5.
I think you're doing minus 9 times a minus 6. Should
I
be
forgot the
54. Is that what you're saying?
negative 5 plus 15 is 10. 2 times 10 is
Yeah, it's
20.
54. 9 times 6 is actually 54.
Ah, what am I doing? So I'm really wrong. Okay, so what happened? Somewhere the check went wrong.
So that other side should be 52 in that case.
This is 54. So somehow the check didn't work. What happened?
Hmm.
You see it, Matt? 12 plus
Negative
2
5.
Should be
negative y minus 3.
6.
5 minus 15 is negative 10, negative 20. Negative 20 plus 2.
Y.
Let's see, let me do it again.
22.
I hate it when the check doesn't work and you're like, okay, this is not what I was trying to do here. 12 plus 2 times 5 minus negative 15. Does that equal to negative 9 times negative 5 minus 1 minus 2?
I think it was the left side, just 5 minus a minus 15 should give you 5 plus 15.
2
I think it's where
20. Oh, there we go. Does that equal to negative 9 times negative 6, which is negative 54 minus 2, positive 54 minus 2. And so that's going to be 40, 52. Yeah, there we go. Check. I'm sorry, it did not mean to take that long on the check. Okay, so let's look at the next couple of problems on the homework. And what I'll do, because I know we're going to run out of time here, is those of you that want to stick with me up and I'll work through all the problems and then we'll post the recording. And so, and I'll also post the, I'll post this just so you don't, if you don't want to watch the whole recording, I'll post all of the work so you can just see it all together. So now we're going to do number 1, 9, 17, and 23. And I left off number 1. Number 1 is just a checking problem. It's just showing you how to check. And we already did that one. We already spent way too much time showing you how to check. So don't worry about number 1. You may omit number 1. And let's do number 9, 17, and 23. So number 9, we have.
Is this a homework or?
Yeah, we're still working on the homework. Which we're running out of time, and because I spent so much time trying to figure out groups. So I'm going to go through all of these, and then I would recommend that you go back through them yourself and make sure that you know how to do them. And if you need to leave at 10:20, then these will all be posted on our website. Okay.
How many questions are in the homework? Like the ones that we just did? Are those the ones or?
Those 3, and then there's several more, and then also the worksheet. Y'all need to do that on your own. And everyone, if anyone's having trouble finding where to go, let me know, and I'll be glad to show you how to do that.
And this lecture video will be posted on the.
This will, and I'll post just the hard copy of the notes as well. So in case you don't want to watch the whole lecture video, but yes, it will be on there. Okay, so number 9, we have 51 plus 5 times 4 minus q equals 56. So what would the first thing be that I would do on this problem?
You move over the 5, which is called distributing.
Yeah. That's right. We're going to distribute. Exactly. We're going to distribute the 5. So that's going to give me 51 plus 20 minus 5q equals to 56. Now what?
Okay, give me a second. Yeah.
Now we're going to combine the 51 and 20, right? And that's going to give me 71.
Okay, this is another case where we drop the parentheses. Okay.
Yes, once you've
Yes.
done the distribution, parentheses are gone. So we have 71 minus 5q equals 56. And now what I'm going to do is subtract 71 from both sides, because I already have the 5q where I
Right.
want it. It's on the left. So I'm going to subtract 71 from both sides. And that's going to give me negative 5q is equal to 56 minus 71. The signs are opposite, so I'm going to subtract, and that is going to give me 15. And the larger of the two numbers is negative, so that becomes negative. And then I'm going to divide both sides by negative 5. And I get q is equal to 3. And I would recommend checking that as well. All right, then number 17. Go up here.
Oh, I didn't see that one was circled.
Oh, yeah, it's kind of, it's not scratched off. You have to kind of be careful. What I would recommend that y'all do as far as these problems, because I've made copies for you, but I would look at the actual assignment, you know, the worksheet, because it tells you exactly what numbers you're supposed to be doing. You know what I'm saying?
Oh, okay.
Yeah, that just to be on the safe side. That's just a good way to.
All right, I'll start with that then.
Okay, so now we're looking at 17. And it's 3 times 4n minus 1 minus 2 equals 8n plus 3. What's the first thing I do?
Distribute.
Mm-hmm. And that gets rid of my parentheses. Okay, now I'm working with this side right here. Now what do I do next?
Well, you can take the 3 and the 2
That's
and
right.
make it negative 5.
That is right. Okay, now both sides are completely simplified. You know that both sides are simplified because there is only one piece that has a variable and one constant on each side. So nothing needs to be combined. Everything is simplified. So now I want to get the variable piece on the left-hand side. So what do I do?
Subtract 8n.
That's right. So that's going to give me 12n minus 8n is 4n minus 5 equals to 3. And then finally, what do I do now?
Add 5.
Mm-hmm. I get 4n equals 8. And the last step would be
Divide by 4.
Yep.
So the reason you wouldn't subtract 3 instead of add 5 is because you're working it from left to right.
Yes. And so what my object always is to get the variable piece on the left and all the constants on the right. That's the object. Okay, then number 23. We have 4 times p minus 4 minus p plus 7.
Number 19.
You don't have to do number 19.
Okay.
Sorry, you guys. Yeah, that's what I'm saying. It's really a good idea to look at the homework sheet that lists all the numbers, because I try to do this just to make it easier for y'all, but sometimes I think it's confusing. Equals to 5 times p minus 3. So what's the first thing I'm going to do?
Distribute the 4.
Distribute the 4. Then what am I going to do?
Distribute -1.
Hmm. Okay, I'm going to just work totally with this left-hand side, so I'm totally through simplifying it, and I'm not through simplifying it yet, right? So I have 4p minus 1p, which is how many p's?
3p.
With 4p minus 1p.
3p.
Yeah, thank you. And then I have negative 16 and negative 7, which is what?
Negative
23.
Yep. Okay, so this side is totally simplified. Now I'm going to go to the other side. And I'm going to distribute the 5. And now both sides are completely simplified, right? So now what?
We would subtract 5p from each side.
Yep. And now what?
Well, we can add 23 to each side.
Yep, because we want to get the constants on the right. And these have opposite signs, so I'm going to subtract 23 minus 15 is 8. And because the bigger numeral is positive, it's positive 8. And then I'm going to divide both sides by -2. Okay, so this is what, these problems that we just did are what we actually want to have happen. We want to actually come up with one answer, okay? But sometimes that won't happen. And so I'm going to go through the other examples of what might happen in the case of you won't come up with a single answer. So before we go on, I want to tell you what we're looking at in these next problems. They're called conditional. Yes.
No, I was gonna ask if I could like leave the class.
You absolutely may. Absolutely. Anyone that needs to leave, I totally know we're over time, and this will be posted, and all the solutions will be written out. I would just really encourage you to make sure you do them. Okay.
And so just do chapter 2.1 homework and then the worksheet.
That is right.
All right.
Right. Yes, sir. Good.
Have a good one.
And the lecture should be up for 2.2.
Yeah.
Thank you, guys.
Yeah.
Yes. Thank you. Bye.
So I had a question before. I don't know how to turn in the papers or like my photos into a PDF.
Have you downloaded Genius Scan?
It's called Genius Scan.
It's a free app called Genius Scan. It does a great job. And you upload that app, and then you just take a picture of everything that you want to submit, and it will combine it all for you in a PDF.
Okay, because I turned in the homework yesterday, but it wasn't a PDF, so I didn't want to get that wrong.
No, you don't get it counted wrong. We'll figure that out, but it just makes it much easier for everyone if you can submit it as a single PDF.
Okay, thank you.
Yeah, sure. All right, so there's 3 things that can happen when we're solving equations. One is that we get a conditional, and a conditional means that you actually get an answer. And that's if, like here, p equals -4. But sometimes you'll be going away, going to town, having a great time, and all of a sudden you come to the end of the problem and the variables just go away. And you wind up with something like this, 5 equals 5. The variables just disappeared, and you wind up with just numbers equaling to each other. Well, if the numbers that equal to each other, if it's a true statement, then this is called an identity. And the solution set is the set of all real numbers.
Is that something you would have to clarify in an answer where you get that?
Yeah.
Okay.
And if you don't want to write all real numbers, there's a little, I love this letter. It's a little double-sided R, just pretty. And that means all real numbers. So you can write that. You can either write, it's an identity, which means the solution set is all real numbers, or just that little double-sided R will do fine. Sometimes you're going along, minding your own business, doing all these wonderful, great things, and you come up with something like this. The variables just totally go away, and you wind up with a false statement. And when that happens, it's a lie, which is another word for, in mathematical terms, a contradiction, which means there are no solutions. And another way you can indicate that is a 0 with a slash through it. Now, I have seen a million, tons of, because I've been teaching for a million years, people that like to cross their zeros just naturally for whatever reason. It's like, don't do that. A /0 means it's a term that means no solution. So if you're one of those people that cross your zeros, don't do that unless you're trying to tell me there's no answers to the problem. So let's look at a couple of these, and so you can see how this can happen. You don't want this to happen. It's always really irritating when you spend all this time on a problem and something like this happens, but that's the way it is. So you have to, it does happen. So if we look at one, like number 31, the next one on the assignment, it says 23z plus 19 equals to 3 times 5z minus 9 plus 8z plus 46. Plus, this is pretty ugly. This side's already simplified, so I don't need to worry about it. So I'm just going to simplify the other side. So I'm going to distribute the 3. And then I'm going to combine 15z and 8z. And negative 26, negative 27, and 46 is what? Positive 21? No, positive 19. Is that right? Yeah. Okay, so I simplified this side. Now I have 23z plus 19. That was equals to 23z minus 19. Okay, now I want to get the z's on the same side of the equation. So I'm going to subtract 23z from both sides. And I get 19 equals to 19. Well, that is a true statement, but it doesn't tell me what z equals to. But that's okay, because in this case, z could be anything. And if you don't believe me, pick any number, 1 or 5 or 11 or 1/2, and plug it into this original problem, and it will solve it. Okay, it will work. So that means any number, any real number will work. So the solution set, this is called an identity, which means any number will work. And the solution set, I like just to write all real numbers. And then one like 33, we have 18 times 5j minus 1 plus 29 equals 47. So I'm going to multiply, distribute the 18, and that gives me 90j minus 18 plus 29 equals 47. So that's going to give me 90j plus 11 equals 47. So subtract 11 from both sides and I get 90j equals to 36. Divide both sides by 90. It's not pretty, but it is fine answer. 36 over 90, which reduces to what?
Like 12 over 10 or 12 over 30, I think would be one.
So 12 over 30, and that'll even reduce further, right?
Yeah.
Because 9 goes into, okay, so 9
4
goes,
over 10, I think, would be as far as you could go. 4 over 10.
2 over 5, right?
Yeah, I got 2 over
Yep,
5.
2 over 5. Yeah, there you go.
Yeah, just keep going until it's totally, but, and that's a fine answer. It's, you know, you get those kinds of answers. That's absolutely fine. All right, so 39.
So that's another true one.
Well, right, exactly. This one actually is just conditional.
Right.
That just means that this is the only answer that will work. Okay, no other answer will work, and that's really what we want, because if any number worked, what good does that do us? Not much. Not in, at least not in algebra a lot of times. But anyway, that's a conditional, and that means that just the only answer is 2/5.
Do you have to specify also? Would you like it specified whether it's conditional or not?
Yes, I would. I want you to write conditional or an identity or inconsistent or contradiction. Yeah. So you do want to say those words as well.
Oh, so we can't use the shorthand?
You can,
Oh, okay.
but also identify if it's a conditional, a contradiction, or an identity. And then you can use the shorthand as well to indicate what.
Well, according to according to one of our papers here, an identity is real.
That's right.
It's true. So isn't
yes.
it the same shorthand for both?
Okay, so an identity, the solution set is all real numbers.
Okay.
So, yeah.
So not all true ones would be that then, because some of them would not have real numbers.
No, all identities have a solution set that's all real. Matt, can you chime in here?
Yeah. So if we're looking at this, it's true. Like you can look like 23 times the number plus 19 is always going to be 23 times the number plus 19, right? If we do that to a number, any real number out there, if we do it to that, it's going to remain. That's a true property of it, right? It's always going to be true, even if we look at the 19 equals 19. Okay, plug in any value of z into that. Well, our z's kind of disappeared, right? And so if we plug in z's, there's really no spots to plug in z's. So it's always going to remain true that like 19 is going to be 19, and it really doesn't. It really doesn't matter what number we plug in. Right?
His question is, why would you, so his question, I believe, and correct me if I'm wrong, Michael, his question is, why do we need to write it's an identity and the solution set is all real numbers?
Well, it really kind of depends like what question they're asking you. If they're asking you what the solution set is, I would say it's all real numbers. But typically, like when we're learning this concept, we want you to recognize like that's an identity. And then we want you to carry that on further that concept and say, well, if it's an identity, then we can plug in anything. And so we really want to see both of those sort of like rationales taking place in your brain, I think is what's happening.
Yeah, right.
Okay, because I'm just looking, because when I was reading my paper earlier, these are the notes, I think is what, yeah, the notes. It says identity, and then it just says solution set is all real numbers, or that symbol. So that seemed like a pretty open and shut definition to me. That's why I was kind of like, is there nuance here?
There's
that
not.
I'm missing?
It's just
Okay.
that an identity is really special because of the property that any number will work in it. So basically, we're just trying to get you to associate identity and all real numbers or go together.
Yeah.
Yes, thank you.
And typically, we'll probably solve a lot of conditionals, and unless they like specifically ask for like you to label like what sort of solution it is, typically like we're not even going to write the word conditional if we do it.
Yeah.
It just happens so much that we get conditional sort of things. Those are your general sort of solutions, and that's generally what they're going to look like. The other two things, the contradiction and the identity, are kind of the oddball for the most part, but they do technically happen just as much as conditional.
Okay, so a conditional would be like J equals 4 over 11 or something like that. Is that conditional?
Yeah.
Yes.
It's true only when you plug in that number, right?
Right.
Any other number we plug in, it's not going to be true. So it's conditionally true for that number.
That is right.
Yeah.
Okay, and then is there shorthand for conditional? I don't
No.
see any.
No,
Okay.
it's J equals whatever. And there are different ways to write this, and we'll get into all that notations very, very soon. But right now you just have to write J equals whatever the number is.
Okay.
For
All right.
me, I have a question of what is contradiction?
Okay, so we're fixing to do one right now.
Cool.
Okay, so here we have, this is number 39, 45 times 3y minus 2 equals 19 times 15y, or not 19, 9, sorry. 9 times 15y minus 6. Okay, so this is going to give me 135y minus 90 equals to 135y minus 54. Okay, now I'm going to subtract 135y from both sides. And I get negative 90 equals negative 54. So what has happened is that the variable has totally gone away, right? It's out, it's gone. But what kind of a statement is this? It does negative 90 equal negative 54? No, right? That's a false statement.
Yes.
So that is a contradiction.
Oh, that's it? That's all you have to solve for?
Yep, and that's no solution, right?
Okay.
So if the variable completely goes away and you have a true statement, then that is an identity and the solution set is all real numbers. If the variable completely goes away and you have a false statement, that is a contradiction, and that means that no matter what, there's nothing that will ever solve that problem. It's not a true statement. Okay.
And before each set of equations, there will always be an instruction of how to solve the problem, like simplify or tell whether it's false or identity.
Yes. But you should have very explicit directions, right?
Okay.
All right, so then the next ones are just ways that you can clear fractions, because a lot of times people don't like fractions.
Can I show something that might like help understand like the empty set too, right quick? Sure. Can y'all see that on my thing up here?
Yeah.
So like to talk about sets, sometimes we use brackets. We haven't gotten to bracket notation, but if you want to think about like a set, this is a set with absolutely nothing in it. We cannot write any number in there, right? Like the previous one, you're talking about like the solution to this. And so that would be like a set with one number. So we can put multiple numbers in here, separate them with commas. We use like the bracket notation. And I talked about it like briefly in the notes, but 0 can also be a solution. So like the empty set is not the same thing as having 0 as a solution, right? Those are different things. If you can,
you know what? People used to get killed over that concept back in, yeah. The concept of 0 was really very controversial. And so like, and when we talk about all real numbers, we could write it like this, and we will, negative infinity to infinity. That means just every number in the universe will work. So that's enough, but we'll talk about all those notations very soon. All right, so these next problems involve clearing fractions if you want to clear them. Some people do not care. Okay, so on 43, we have 1/4 x minus 1/2 equals to negative 3/4. A couple of things. If you have 1/4 x, that is the same thing as x over 4, okay? And then minus 1/2. And anytime you have a negative fraction, I always just make a point of putting that negative on the numerator, okay? It doesn't matter, you can put it in the numerator, you can put it in front of the division bar, you can put it in the denominator. Just makes your life easier if you have it in the numerator. Now we have these fractions, and a lot of us don't want to work with fractions. So what we do is I will pick the lowest common denominator and multiply everything through by that number. So the lowest common denominator, what is a number that both 4 and 2 will divide into evenly?
12.
Okay, 12, but that's not the
8.
lowest.
8 is another one.
And what's even lower than that?
I don't think there's anything lower than 8.
It's 2, right?
No, okay, so 4 will not divide into 2 evenly, right?
Right.
But will 2 divide into 4 evenly?
Yes.
Yes. So what I always do, and I think Mike, well, I actually think you suggested this yesterday, pick the biggest number and see if the other numbers will divide into it. And if so, that's the lowest common denominator. So I pick 4 and everything, all those denominators will divide evenly into 4, correct?
Mm-hmm.
Yeah.
So that's what I'm going to be multiplying everything through by is 4. And remember, 4 is the same thing as 4 over 1. Okay. So if I do that, I'm distributing this, and oh, here's big star. Don't forget to to multiply it by every single term in the equation. Can't tell you how many people, including myself, will sometimes forget that last term, the other side of the equals mark. So this would give me 4x over 4, right? Because top times top, bottom times bottom, minus 4 times 1 is 4, 1 times 2 is 2, equals negative 3 times 4 over 4. So that just gives me x minus 2 equals to negative 3. And so that.
Real quick, I'm sorry to interrupt.
Uh-huh.
Can we just back up a little bit, right back to LCD where 4 equals 4 over 1?
Uh-huh.
I'm sorry, I kind of missed out on this part. You put the brackets in between the equation. I wanted to know, supposed to do that every time or just
Okay, so actually what's happening is that you know that anytime you do an operation to one side of an equation, you have to do exactly the same thing to the other side of the equation, right?
Right.
So usually what I do is I put brackets around the whole thing just to remind myself to apply that 4 over 1 to every single term in the equation.
Okay.
Okay, otherwise sometimes I'll forget the end.
Understood. Just wanted to make sure because that's not what I did, but I didn't want to get any points taken off for not including the brackets.
Oh no, you do not have to put them there. That absolutely don't. It's just a way I remind myself.
Okay, just checking. Thank you.
Sure. And then we're going to add 2 to both sides here, and we get x equals negative 1, and that's it. Okay, so 45. We have 5 over 6y minus 2 over 3 equals to negative 3 over 2. Okay, what's the lowest common denominator?
3.
Okay, will 2 go into 3 evenly?
Oh.
6, right. 6 goes into 6, 3 goes into 6, and 2 goes into 6. So our LCD is 6. So I'm multiplying 6 over 1 times 5y over 6 minus 2 over 3. And, okay, and sometimes I put the 6 over 1 on both sides. Okay, so now when I did this is a whole lot of writing over here, right? So I can, if I want to, I don't have to write all that out if I don't want to, because when I multiply these 2 together, what's going to cancel?
The 6.
The 6's, right? What am I going to be left with?
30y.
5y. You can't read my handwriting. That's 5y, right? Everyone see how that happened? The 6's canceled, and I just get 5y?
Yes.
Okay, when I multiply these 2 together, how many times does 3 goes into 6?
2.
And then 2 times that 2 on the top would be?
4.
And what kind of 4? Positive or negative?
Negative.
Yes. And then here, how many times does 2 go into 6?
3.
And 3 times negative 3 would be?
Negative 3. 3 times negative 3. Yeah. Oh.
Does everyone see how that works? The 2 goes into the 6 3 times, right? And then the -3 times 3 is -9. And if you don't like that, you can show all of this stuff right here too. That sometimes it's okay. So then I'm going to add 4 to both sides. I get 5y equals to -5. Divide both sides by 5, and y is -1.
So you did this problem a little bit different than you did the last one.
I just didn't show all the steps.
Okay.
But you can't, I mean, you can definitely show all the steps if it makes it easier for yourself.
So rule of thumb for fractions would be to always find the lowest common denominator, put it over 1, and distribute it and work the problem that way.
That's right.
Okay.
And if it doesn't clear the fractions, then you've done something wrong, because the whole object of multiplying by the lowest common denominator is to get rid of the fractions.
And the same with subtract. Once you get past that, once you're like where you are adding 4 to both sides, you would, you can always do that. This is just
Right.
a whole process. What would you call this?
So I just call it clearing fractions. We're just solving an equation, but it's got fractions in it. So a lot of times that intimidates people. So it's real easy or fairly simple to get rid of the fractions if you just multiply by the lowest common denominator. And then it just turns into an easy, solving equation.
Okay.
Real quick, before you distributed 6/1 into 5y6, how did you come up with y? Real quick.
With what?
How did you come up with y after distributing 1 into the 5y/6?
6/1, okay, times 5y/6.
Yeah, and how did you come up with 5y?
Okay, because the sixes would cancel, right? Because 6 goes,
Okay, right.
and then you end up with the 5y. But the reason I don't want to cross that out is because I need to use it again when I do this guy, right? Right. So because 6 and 3, that would turn into a 2, right? When you do it with the term. So that's why,
And the 2 multiplies and becomes -4, and then
that's right. Right.
Yeah.
So
All right.
basically, you're dividing the numerator and then multiplying. You're dividing the numerator of the 6 over 1 by the denominator and then multiplying by the numerator. That's
understood.
Okay. All right. So then 57, and this is, be careful on these, and I'll show you why. 1/2 times x plus 4 equals 3/4. What I would recommend that you do on this one before you try to clear the fraction is go ahead and distribute that 1/2 first. So that would give us x over 2, right? Stop me if I do something you don't like. And then 1/2 times 4 is what?
2.
It's half of 4, 2. 1/2 of 4 is 2 equals to 3/4. So this is the same thing as 2/1. You can write that if you want. You don't have to. What's the lowest common denominator here?
2.
Okay, does 4 go into 2?
Oh, crap.
That's what you always have to ask yourself.
I don't have myself. No. 4.
4, right. So I'm going to multiply all of this by 4. Okay, so if I multiply 4/1 by x over 2, how many times does 2 go into 4?
2 times.
2 times. And 2 times x is 2x, right?
Right.
Plus, okay. How many times does 1 go into 4?
4 times.
4 times. And 4 times 2 is?
8.
8. How many times does 4 go into 4?
1 time.
1 time. And 1 times 3 is?
3.
3. Okay, so now I'm going to subtract 8 from both sides. That just turns into a simple equation, right? and divide both sides by 2. Now this -5/2 is a perfectly fine answer. You can just leave it -5/2. If you want to write it -2.5, that's fine. If you want to write it -2.5, that's fine. But -5/2 is a completely fine answer. Okay, the last problems are, and again, some people don't, the decimal parts don't bother them. So I'm just going to call this clearing the decimal. But again, you don't have to do this if you don't want to. Okay, so notice we've got these decimals here. Not really a problem, especially if you're using a calculator. You do not have to worry about clearing them if you don't want to, but some people like to clear them. Notice that everything is in the 10th place, right? All the decimals are in the 10th place.
Yes.
So that means I'm going to multiply every single term by 10. So I'm going to multiply every single thing by 10.
When
Okay.
we're writing decimals here, do we always have to put the 0 in front of the
You do
point? Or can we
not.
just put point? Okay.
You can just put the point, yeah.
I was wondering if there's some kind of rule regarding the
No,
zeros.
no, you can leave it out if you want to. All right, so anytime I multiply a number that's in the 10th place by 10, the decimal goes away. So 10 times 0.4x is just going to be 4x. 10 times 0.6x is going to be plus, did I write that problem wrong? Oh, there shouldn't be an x there. I put an x. Where did it need to be? So that's just 0.6. It's just going to be 6. 10 times 0.5 is just going to be 5x. And 10 times -1.2 is just going to be -12. So now you've gotten rid of all those decimals, and now you just solve it like you would any other problem.
So if it was in the hundreds place, you would multiply everything by 100.
Absolutely right. Okay, so and that's such a good question. Let's say that instead of this problem being like this, and just pretend, let's say it had a 0.25 on there. This one you would have to multiply everything by 100. So whatever the furthest place is, that's the number you multiply by. Does that make sense?
All of them?
All of them, right?
Okay.
Right. Okay, so negative x equals -18. So x is equal to positive 18, right? Because I multiply both sides by -1 and divide both sides by -1.
Yes.
So this is what you were just talking about. Number 69 is exactly what you're just talking about. We have 0.05 n plus 0.10 n plus 8 equals to 2.15. Okay, so what I would recommend again, just to avoid confusion, is to go ahead and distribute that first. So that's going to give me 0.05 n plus 0.10 n plus 0.80. And that 0 here and that 0 here, you don't really need it, but I'm putting it in there just so that everything looks like it's in the hundredths place, equals to 2.15. I'm going to combine this guy and this guy, and that's going to give me 0.15 n. And this time, what am I going to multiply the whole thing through by? And I could have done it even before I combined the like terms.
100?
100, yes, because they're to the near, they are numbers that the furthest place is the hundredths place. So I'm gonna multiply everything by 100, and that is gonna become 15n plus 80n equals to 215. And that's gonna give me 95n equals to 215. So n is 215 divided by 95. What's that come out to be? And that's going to be 43/19. Okay, the last problem, and thanks y'all for hanging in there with me. And again, I'll post all of this. So, and tomorrow I promise will be better. Fencing, this is just trying to give you an application, but let me just tell you, generally speaking, don't let the application problems in any way, shape, or form intimidate you, because half the time they give you like, oh, here's an application, but then they just give you the problem. So like, for example, on this one, it says, Micah has 74 feet of fencing to make a dog run in his yard. He wants the length to be 2.5 feet more than the width. Find the length by solving the equation. So all you have to do is solve the equation. You don't even have to set it up. They're telling you this is the equation to solve the problem. So we have 2L plus 2 times L minus 2.5 equals 74. And now all you have to do is solve that problem, just like we've been doing for all the rest of the problems in this. So we'd first start by distributing. Then I'd combine the L's. Then I'm going to add 5 to both sides. And then divide both sides by 4.
I don't know what that is. I don't think that's. I think you can simplify it maybe, but I don't think you can solve it.
So that's it. No, that's as far,
decimal.
yeah, that's as far as you can take it. You can put it as a decimal if you want to. And probably in this problem, it would be better because it kind of makes more sense. That would be 19.75 feet.
Okay.
Yeah, but you could just leave it 79/4 if you wanted to. Okay, so does everyone know what they are supposed to do from here?
Do the graded problems.
Uh-huh.
Yeah.
And submit both what we just did right now and the graded problems before midnight tonight.
Okay.
Okay. And if you have any questions or problems, just let us know.
What are the graded problems?
The graded problems, okay, let me show you. Hold on just a second, I'll bring this up. Okay. So if you look over here on this column right here, under class documents, there's homework worksheets. Click on that. We've already done, this was Monday homework trial run. This was Tuesday, chapter 1 homework. This is yesterday's homework. No, I'm sorry. This is today's homework right here. Mirror check 2.1. This is what we're working on today. The written homework, I've tried to consolidate it for you in the book. I've tried to kind of put it in all together in one place for you. And then the graded problems are right here. And if you ever are not sure about what the bookwork is, it's always right up here. It tells you exactly what it is. It's just kind of, I just think it's kind of convoluted because it's kind of hard to find if you're looking at the main book. So these are the graded problems. This is what you need to do. And those will be graded. And what we just did counts as 50% of the grade, and this counts as the other 50%. Also, just FYI, I also put in here under the textbook. So if you do the download PDF, that downloads the whole book. But if you click on here, mirror check problems and solutions only, that will just give you, it takes a minute to pull it up, but it will just give you the homework problems and the solutions. Let's see, it takes a second because it's still a lot of stuff. Oh,
I was gonna say if they haven't done Merit Check Chapter 1, like I haven't graded that yet.
Oh, so yeah, so you can go ahead and like if.
Yeah, I know, and I know there was some issues with Blackboard yesterday. I like saw the emails this morning and didn't get a chance to really respond. But
yes, I'm sorry. I just wanted to say that I was unable to submit. So if I am able to submit it, that would be cool. I had college algebra only show up on my Blackboard, and everything, all the assignments are under your MA.
it should be under the college algebra site.
Well,
The 13,
it's 2 different courses, right? MATD.
Yeah, there are 2 different courses, but
you can't even open one of them.
I don't think. Yeah, I don't even think you can see hers. I think you can only see mine, the 13-14. So we're doing everything on the 13-14. We're not even using the other one.
You should be able to see the other
issue I was having, that I could only see out the college algebra, and there's nothing on there. But I can see it now. I could since this morning. Yes.
Okay. All right.
Okay. Yeah, they fixed it.
Yeah, and you right now, I think this week we're really we're being very lenient in the first week, especially about, just get it in. And we'll, we know there's problems at first. So okay. So Matt, I'll do tomorrow because you're doing Monday and Wednesday of next week, and we test on Thursday, and you've done most of this week. So I'll do tomorrow, and then Monday and Wednesday, and if you want, I'll do next Friday or not, or you can do next Friday, whatever you want. But by that time, okay.
Yeah.
Okay.
That's a few days away.
Yeah. All right. So, okay. Are there any questions?
Yeah, I do have a couple questions.
Okay.
So, for Blackboard, there's also these 2 classes that are like combined together, but like they're in 2 different categories on the Blackboard. Like English composition and then integrated reading and writing. Like, is it supposed to be like one class like combined? Because that's what it was originally.
Yes, probably so. And I would ask your professor about that, because probably if it's like our classes, when we have the combined classes, all the record keeping is kept in just one of the courses.
Okay, yeah, because like one professor like hasn't assigned anything, and she said that we'll have a Zoom meeting on today at 12 for any questions, and then the other professor did sign us like a essay. So I was just curious.
Yeah. Well, I don't know actually, because I have taught classes where there are 2. So I lied to you. If both professors are meeting in the same time frame, then you usually only use one. But if they're meeting in 2 different time frames, you probably will have 2 separate grade books.
Okay, that makes sense.
Yeah.
And so when it comes to like submitting our work, like, so we can't take a picture of like the work that we did?
Use Genius Scan. Don't just take a picture of it, because then what happens is you're submitting a whole bunch of different documents and they're JPEGs, We want it as, so we really want it submitted as a single PDF document. And if you download an app like Genius Scan, that it does it really easily for you.
So I download Genius Scan and just take a picture of.
Right. And it'll combine everything for you. Right. It's super easy. It's very
Okay, thank you.
Yeah.
That was very helpful. I was doing like some other way and it was like time consuming.
No, that's my favorite. But.
Yeah. But
Is
that's
that
all the
count-
questions.
Sorry.
Okay.
Is that connected to Blackboard?
No, you actually have to use Genius Scan. You take the pictures on your phone using Genius Scan, and then you upload it into Blackboard.
Okay.
Are we done recording today? I think.
Oh, yeah.